first thing I want to point out for this section is that the ratios of trigonometric functions don't change at all by the size of the triangle. So if we had a small triangle, as we know, like a unit circle has a hypotenuse of 1, and let's say I have a rise of, let's say, 1/2, and I look at this angle, right? The sine would be opposite. The sine of 30 degrees would be opposite over hypotenuse, right? Alright, so if we do opposite over hypotenuse, that's just 1/2 over 1, which just equals 1/2. If we scale this up and like double it, right, and I can go, let's say, make this 2 and make this 1, well, the sine of 30, if you calculate it, right, is still 1 over 2. So just pointing out the idea or the concept that no matter how big or how small what you're working with, the ratios do not change. So if there's a 30-degree angle, the hypotenuse and the opposite side always make the same ratio, no matter what. Right? So whether you're constructing the bridge of a roof that has a peak, or you're making a pyramid, right? Triangular, it's still going to have the exact same ratios. So keep that in mind just as we go through here, because sometimes we falsely think that somehow a bigger triangle will have a bigger sine or something like that. So it's not how big the actual triangle is, it is the actual angle. If the angle doesn't change, the sine does not change, okay, for 30 degrees or any set 1 degree. So just worth mentioning to put it out there, okay? Now, majority of what we're doing today is going to be looking at something called the reciprocal circular functions. So circular being trigonometric, sine, cosine, and tangent. Now let's take the reciprocal of those and see what those look like. So reciprocal, as you probably learned when you divided fractions, you learned what a reciprocal was a long time ago. If you divided by, some number divided by 3/4, you learned to solve this problem by doing, well, that's going to be a over b times its reciprocal, 4 over 3, which just meant to, flip the second fraction. Okay, which does work in practice, and you can use that today. The technical definition is to do the reciprocal is just 1 over that. So if I do 1 over like AB, something like that, or actually I should use 3/4. So if I'm doing 3/4, right, that's going to make the reciprocal of 4 over 3. So keep that in mind, because we can do, when you're asked to take the reciprocal, you could do it either way. You could just flip the fraction, or if that doesn't work, you can do 1 over the original, simplify it, and that'll give you an answer as well. So that's just 2 ways, 2 approaches to doing the same thing. And our reciprocal functions are right here. Okay. Close enough. Alright, so we have a reciprocal function called the secant, right, which is the reciprocal of cosine, right? So if cosine, which is, what is that, adjacent over hypotenuse, right? The reciprocal of that is going to be hypotenuse over adjacent. So just straight up, just flipping it around, okay? There's different reasons why we'd use secant over cosine. We'll get to the practical uses later on, but today we're just defining it. The cosecant, or the complement of the secant, is the reciprocal to sine, right? Which we know, of course, is opposite over hypotenuse. And that will equal hypotenuse over opposite. And then, of course, we have the cotangent. Cotangent, complement of the tangent, which is just reciprocal. So we have cosine over sine, which is kind of unusual because we're so used to rise over run. Technically, this is run over rise, or x over y. So it's just the reciprocal. Okay. So what we're going to do is the same thing we did yesterday. but using these. So if we're good on yesterday's homework, today is going to be just kind of, okay, just to change things a little bit, and we're good to go. Okay. So let's practice I'll practice one of these with you, and then you can do the next two. Yeah. So secant, it says draw and label the reference angle and reference triangle, and then evaluate what is the secant of 5 pi over 4. All right, so what quadrant is this in? The first question is always, where are you? You say, where am I? Where is 5 pi over 4? What quadrant, and what is the reference angle? Quadrant 3, and it is a 45 degree. So that's where you kind of want to be heading if you're not already there, to be able to look at this and say that, you know, kind of like what's 4 times 5, right? And it becomes our new multiplication table for higher math, is knowing the unit circle. Now, if not, just remember and recall from yesterday that this is 4 over 4 means 45 degree increments. That means we need to go 5 45 degree increments, which would be 1, 2, 3, 4, and then the fifth one would be where we landed. Okay? Or you could look at this and say, well, 4 over 4 would be pi, so 5 over 4 would be 1 45 degree angle after pi. So that's another way of looking at that. This is a little bit bigger than half the full unit circle. Okay? But we have to know where we are, because that's going to determine what our cosines, sines, and all that equals. All right, and in front of the unit circle, we know this is a hypotenuse of 1. What is the sine and cosine? What is the rise and the run of this? Right, so this is where we can say, if we don't remember, we know this is a 45, 45, 90. How do you go from the hypotenuse to a leg with a 45, 45, 90? Divide by root 2, and then you got to rationalize it. So once you rationalize it, that's how you get root 2 over 2. So if you ever forget, right, what the value is, you know, you can recreate it. You can say, well, it's a 45, and you know it's a 45, 45, 90. You can go off to the side and like, oh yeah, root 2 over 2, after you rationalize it, of course. All right, that turns into root 2 over 2. And that's the same for both sides, since this is isosceles, right? We don't have to do it twice. Okay, and of course this is root 2 over 2. All right, what's wrong with my answer so far? What's wrong with these answers? Yep. No, for just these numbers here. How come these are not the right numbers? Right, so what should they be? Negative. Yeah, we're in the third quadrant. All right, so we're not going to get that from doing it over here. We have to, you know, kind of acknowledge we're in the third quadrant. Both cosine and sine, x and y, are negative, and we have to remember to do that. That's the whole reason of asking ourselves, what quadrant are we in? Is so we get the signs right. So if you ever hear me say that, so what's wrong with this? I'm probably referencing, okay, check your positive negatives, right? Because that's telling you every single time, that's the most common mistake, is you don't know where you are. You don't know what quadrant you're in. Okay? So keep on saying it, so that you're ready for your quiz. All right. Now, we still have to find this, right? So now that I have this, right, I can look at this and recall secant. Let's go back to my notes. Secant is hypotenuse over adjacent. All right, and you can write this out each problem, just till you help you remember it. And I go to my hypotenuse, and I find it at that is equal to 1. And I go to my adjacent, which is right here. That is equal to negative root 2 over 2. Which just makes this a reciprocal. So we have 2 over root 2. So remember, 1 over a fraction, that's the same as a reciprocal. That's the part that I opened with at the very beginning up here. 1 over a fraction is just the reciprocal. Okay. Of course, this is not finished, so we have to rationalize it. So let's multiply by root 2 over root 2. And we got negative 2 root 2 on top, 2 negative 2 root 2. And on the bottom we got root 2 times root 2, which is just 2. So that simplifies even more. All right, 2 divided by 2 equals 1, cancels out. So we have negative root 2 as the secant of 5 pi over 4. Okay, there we go. Cool. So I'll have you try that. Same process with cotangent. So I'll start you off here. First of all, where are you? Quad 2. Good. What's the reference angle? 30 degrees. Yep. We know it's 30 degrees because it's divided by 6. If you go look at your unit circle that I passed out yesterday, you'll notice they're all in light blue, right? And they're all divided by 6, and they all have 30-degree reference angles. Right? So I can fill this out. I know hypotenuse is 1. This is the long side is down. This is stretched out triangle, not a tall triangle. So I know the long side is root 3 over 2, and I know that the height is 1/2. And that's from a 30, 60, 90. That's from based upon yesterday homework and back in geometry as well with 30, 60, 90 triangles. Okay, you know my next question is? What's wrong with it? Which one's negative? Yeah, right, because we're on the left side, so cosine is negative in quadrants 2 and 4 because this is the negative x range. So check that one more time before you start working. Okay, so now that you got that, go ahead and finish that up. I think number 2 didn't show up on yours, but that's number 2 that you can try after you do number 1. Check with each other. Try to do number 2 on your own and see how that goes. All right, go at it. So we look at this. We have all 3 sides written down. Let's remember what cotangent is. It's run over rise, adjacent over opposite. Okay. So adjacent to this angle is negative root 3 over 2. And opposite this angle is just 1/2. And that will simplify simply to negative root 3. Now, if you don't see how I got there so quickly, all I'm doing is just multiplying by the reciprocal top and bottom. So the denominator is gone, and now these 2's cancel out, and I'm left with just negative root 3 over 1, which is negative root 3. So you'll notice if I go backwards, if you have 2 fractions in a complex fraction, and they have the same denominator, basically these just cancel out, right? So I have negative root 3 over 1, which is negative root 3. Perfect. Okay. Do you need more time for number 2, or are we good? Do we know where we're at? What quadrant? Okay, start there and then figure out the reference angle and then go all the way with it. Give you a little more time. All right, so what is the reference angle? What is the quadrant? Quadrant 4 and 60 degrees, right? So as soon as you saw this was over 3, you know it's 60 degrees, right? That's a 60-degree angle. We have, of course, that. And now this is going to be one of the taller 30, 60, 90s. So instead of the run being root 3 over 2, since this is one of the taller ones, we know that this is the rise is root 3 over 2. And that this is 1/2. Okay? How do my signs look? Wrong. Yep. So the rise, this is going down, right? So I know this is a negative root 3 over 2. So Always check those signs. Okay, now we're ready to do cosecant. Right, which is going to be, check your notes, cosecant, hypotenuse over opposite. We've got 1 over opposite, which is negative root 3 over 2, which is just the reciprocal. Oh, wait a minute, that's wrong. Negative root 3 over 2, which is just the reciprocal of negative root 3 over 2. So we get negative 2 over root 3, and then rationalize. So we solve this. So we have negative 2 root 3 all over 3. Nothing simplifies, so we'll just leave it like that. Alright, so it takes a little bit thinking, but we can handle this, right? We just have to stay organized, and step 1, figure out where you're at. Step 1B, make sure your signs are right. Then use your notes to, decode cosecant, cotangent to make sure you get, adjacent over opposite, hypotenuse over opposite. At some point, it'll just be natural you memorize it, but have your notes out, have the unit circle out while you're doing this. That's why we do this, right? And it'll help you out. All right, let me pass here. On the front, you have a couple triangles. You have a couple triangles, and you just have to go through and do what we just did, and say, well, first decode what is cosecant, right? Hypotenuse over opposite, and then use the right angle over here and just do the hypotenuse over the opposite, right? So it's just going to equal a ratio or a fraction that you can reduce possibly. So that first part is straightforward, good practice. We get down here, it says find the exact trigonometric function. Exact value for each trigonometric function. So it's cosecant, and a lot of these, see 3 pi over 2, these are the 90-degree intervals, right? So you could refer back to your unit circle to help you out, but I would suggest that you do the reciprocal first. So let's look at this. So if you know cosecant, the reciprocal of cosecant is sine. So what's the sine of 3 pi over 2? Right, what does that equal? And then you can just do the reciprocal of it. So really, this is going to equal just 1 over the sine of 3 pi over 2. Okay? So 1 over, and what is the sine of 3 pi over 2? What is the rise of 3 pi over 2? And you get negative 1. All right? And you can look at your unit circle to confirm that, right? And so the answer is just negative 1. Then we got something like the cotangent of pi. So we can do it this way and say it's 1 over the tangent of pi. So what is the tangent of pi? What is the slope of pi? 0. So this equals undefined. Yes. Okay. So that's why I was saying earlier, when you're asked to do reciprocal, sometimes it's easier just to do the 1 over, not just get the answer and then flip it. Because especially for these, that the answers of zeros turn into undefined. So it's not technically correct, but it is, they're associated, like the reciprocals of undefined and 0 are kind of like reciprocals. So if it had an undefined slope, the reciprocal of it will be 0 and vice versa. Okay. And lastly, go ahead and flip it over. So if we have our information now, we can be given just one of the 6 trigonometric functions. So we now have sine, cosine, tangent, right? Cosecant, secant, cotangent, right? So we can find all of them if we're just given one of them. So I'm going to show you how to do that. And this is a really important skill right here. And there's a couple steps. So first off, let's write the question down, what we're really trying to do. So our goal by the end of this is that I can write all the trigonometric functions. So cosine, secant, and I like writing the reciprocals below because it's just going to be the reciprocal. Let's see here. And we got the, what's next? Sine, theta, and then cosecant, which is what they gave us. And then lastly, we're going to find tangent of theta and cotangent of theta. Awesome. So some of these were going to be straightforward. So for instance here, cosecant is given to us, so I can just write that in. Be negative 5 over 3. And then we can get sine as well. That's just the reciprocal. So I can write this as negative 3 over 5. So the first initial one we can do immediately because it's just a reciprocal. However, you know, we can't do these other ones because I don't have the third side of the triangle, right? That's what these are. This is a hypotenuse, right? This is an opposite. But I don't have the adjacent, so I can't do all of these that cosine requires adjacent. And I can't do tangent because it's opposite over adjacent. So what we're going to do is draw a triangle and figure out what the missing side is, and then I can go back and do it. Now, once again, it gives you the information. It kind of gives hints and clues of what quadrant you're in. So we're going back to the same game. Is where am I? Where am I? What quadrant am I in right now? So we look at this carefully and we see, well, cosine is positive. That's the x-coordinate, right? So that must be over here someplace. So right now I'm stuck with 1 or 4. But sine, as we already found out, sine is negative. So what quadrants are those? Yeah, that's the y-coordinates are negative. So that means we end up in quadrant 4 is what we're working with. Okay? So we're in quadrant 4. So now I'm going to draw that triangle, right? Now that I know where I am, I'll fill in what I know. Like my sine is negative 3 over 5, so that's opposite over hypotenuse. Notice how the negative's just floating in front. You might be thinking, well, which one's negative? The hypotenuse is always positive. So if you have an hypotenuse, it's always positive. So that means the opposite definitely is negative, which makes sense. It's going down, so it should be negative. And then we have to find the missing side. So you might have to do this, right? Figure out what the missing side is, but this is a right triangle, so we have Pythagorean theorem to help us out. We can call that x. And go through and solve it. You'll end up with x equals 4. Now, if you recognize from the very beginning this is a 3, 4, 5 triangle, you don't really need to do this part. A lot of these are going to be those Pythagorean triplets. I think on the day 2 we did a short review on Pythagorean triplets, which are Pythagorean numbers that all come out to be integers, all 3 sides. So we try to use those as much as possible. So if you catch on, or if you look back at your notes on that part, you can probably skip all this. If not, just go through the Pythagorean theorem and solve for the missing side. Sometimes you're missing a side, sometimes you're missing a hypotenuse. It just depends. Okay, so now since I have all 3 sides, right, I finally know that this is equal to 4, and it is positive 4. Now I can do these other parts. I can do adjacent. Anything with adjacent, since I have 4, I can now do that. So I start here, say cosine is adjacent over hypotenuse, 4 over 5. And the secant will be the reciprocal, 5 over 4. So it's kind of like a buy one, get one deal. And now we can do tangent or slope, right? Which is rise over run, tangent, negative 3 over 4. And its reciprocal is cotangent, negative 4 over 3. Do note that how I left the negative on top here, you generally do not, because the negative's on here, you might be tempted like to, just put the negative on the bottom and do something like this. But you don't see any problems with a negative in the denominator. Just like the radicals in the denominator, right? So either leave it on the top or put it in the middle, right? But we don't put negatives on the bottom. All right, so that's how you go through there. It's kind of, it shows that you know an awful lot when you're able to do these. So these involve a lot of things. You have to know where you are. You have to do a Pythagorean theorem, right? You have to know, the trig functions. You have to know if it's opposite or adjacent or opposite, and all sorts of things. So this is bringing a lot of different things together from multiple classes. So it's a good test to see where you're at. Okay, so I'll let you work on this. You got some time. Again, ask questions before you leave, and I'll see you tomorrow.